Hello everyone, in this video we're going to be talking about linear regression. We're first going to recap what we've talked about in the previous week with correlation coefficient using the data given on this first slide. So the low temperature we're going to treat as X or L1, the high temperature we're going to treat as Y or L2. So the correlation coefficient, that's the whole diagnostic on feature on the calculator. Remember, it tells us the relationship between the two variables. The closer it is to kind of the outer boundaries of 1 or -1, the stronger the relationship. The closer it is to center or 0, the weaker the relationship. So in this case, if you did this correctly on your graphing calculator to the nearest thousandth, you should get, I don't know why this is always a random color. I get 0.922. There's no rounding. It's pretty low digits early on there. So 0.922. So this is a very strong relationship. Another linear model predicted the temperature based on humidity. For this model, the correlation coefficient was 0.85. Also pretty strong. Which model does a better job? So obviously our model is going to, or the one we were given here, the low versus high. And why? Because it is closer to 1. It's, while 0.85 is still a strong relationship, 0.92 or 0.922 is even stronger. It's closer to 1. So this was recapping correlation coefficient from last week. We're going to talk about something similar and also related back to scatter plots from Friday with what's known as linear regression or line of best fit. So this line of best fit, it's also called a regression line, a trend line, has a few different names, is basically given a scatter plot. So pretend this blue line wasn't here for a moment. Let's just say this was a scatter plot, these little yellow dots looking at temperature versus money for some reason. I'm not sure what the variable is there. The trend line is the line that best approximates the points. Notice it's not passing through all of the points. First of all, it has to be a perfectly straight line. So that's never going to be possible unless it's a perfect correlation of literally 1. So remember, the closer the correlation is to 1, the closer it is to a straight line. So if it's literally a perfect fit at 1, that would be the only case where it passes through all the points. What the line of best fit's doing is exactly what the name says. It's trying to pass through or approximate the points as best as it can. It's kind of like slicing down the middle of them. It might miss some by a decent amount, but it's kind of like approximating the middle of how the points fall. And you can see, just comparing left and right here based on what we talked about Friday, I would say without even calculating anything here, I'm going to venture a guess that this is a stronger correlation than this one is. While there's some pattern here, it looks like the points are generally increasing, they're kind of more far apart. So they're not as close to a straight line. This would probably be a weaker relationship than this one. Now, what we're going to be doing in this lesson is not only creating this line of best fit, but we're also going to be utilizing it with what's known as extrapolating, using a given equation to kind of predict something that might happen later on down the line that's not featured on our graph or not featured on our table. And that's the whole real purpose of this trend line. So just kind of answered this question on the last slide, but how can a line of best fit, trend line, regression line be useful? Obviously, it can tell us information that we're not available to just yet. If I have a table of values or a graph like this, and I want to know, so this is chapters versus typos. If I want to know how many typos you would find in, let's say, 18 chapters, other than just making an educated guess, having a trend line that you can kind of use to plug into might be more beneficial. And you can kind of use that to give you an idea of stuff that's going to happen either later on or maybe something in the middle. Maybe sometimes you want to know something in the middle that, once again, you don't have a value for. You can use that trend line to kind of give you an idea. So based on this example here, it's a pretty fair guess to say, hey, if you were to write 10 chapters, there'd probably be, I don't know, around 13 typos. This line of best fit would probably look something like this. So 13, and we're just eyeballing and doing this mentally here, would probably be a good bet. Now, strategy-wise, we're pretty much just like most statistical topics, we're just going to be relying on the calculator. We've been doing lin-reg for a while, and I think I've said it a few times, that stands for linear regression. So we're going to be using that lin-reg feature on the calculator to come up with the equation for us. Unlike earlier in the year where we used linreg to come up with an equation and we got like 4x minus 3, these are going to be very crazy because remember, they're not accurate. They're not passing through all the points. So they're going to have like 10 decimal places. So usually, can't talk. These questions will say like round to the nearest hundredth or round to the nearest thousandth, just because there's so many decimals when you're using your calculator. All right, these steps are laid out for you here. Like I said, I think we've used this quite a bit, but just in case, we're going to enter the data into our list, L1 and L2. There was a few people that were having issues last week with correlation and stuff like that. What happens is you ended up deleting a list at some point, maybe by accident. Maybe you just kind of randomly hit some buttons at some point and a list was gone. That's going to mess things up when you try to do linreg or you try to do correlations. The best bet is just to reset your calculator if you're noticing like a list is gone. You're then going to hit stat, stat, scroll over to calc, and we're looking for linreg, which is choice 4. You could either hit 4 or scroll down and until it's highlighted and then hit enter. It's going to ask you what list you want to use. It should be defaulted on L1 and L2. And this is what I meant earlier. Notice we're not getting like a nice clean answer because it is a line of best fit. It's going to be something crazy because it's so specific. So usually these questions will say round to nearest 10th or 100th. While it's always great to have diagnostic on, this has no impact on regression. That's just for correlation. All right, and for this table that we're given here, we're going to find the line of best fit using fat versus calories. Just for argument's sake, we'll kind of treat total fat as X and calories as Y, or like L1 and L2. Now, typing this into my calculator, once again, anytime you enter data in, you want to make sure you're not missing anything. You didn't hit a button by accident, because obviously that's only going to lead to a mistake. And if you did this correctly, rounding to the nearest hundredth, our trend line, our regression line, should be, the slope is 11.73x plus 193, 0.85. Okay, that's all for me just typing this in under L1, L2, stat calc, linreg. Now, this is where we're going to use the trend line. We've talked about, hey, why would we care about having a line to represent this relationship? Because now we can use it for something that wasn't featured in it. I didn't know Taco Bell's breakfast crunch wrap. That's not in my table. However, I could use this almost as like a calculator, for lack of a better term. I can plug into it and get a value that kind of fits the rest of the table. So it has 22 grams of fat. What would be a good prediction? At the end of the day, this is still a prediction. We don't know exactly. Remember, it's not an exact type thing. It's a line of best fit. If I plug in 22 for X, you could use, I guess, Y equals if you wanted to here, maybe. You could type like the equation into Y equals, or you could just do it like how I am. 11.73 times 22 plus 193.85. While crunch wraps are delicious, they would have 451.91 calories. Does it say rounding wise? Doesn't say where to round. The rest of the values are rounded to a nearest number, so I'm going to do the same. Let's just say 452 calories. It would be an estimate based on our line of best fit. All right, some vocab. While I always mention like we're not going to have a vocab quiz where you're going to have to know the difference between these, it's important just math vocabulary wise, being familiar with terms such as these. The first one is interpolation. That's basically predicting values that fall within your scatter plot. So if this was my scatter plot here and I wanted to know someone's test score based on 3.5 hours of sleep. So I don't have a value that's there. However, I can create a trend line, and then I'm kind of using that trend line to find something that's within the already given values. Now, extrapolation is predicting something later on down the line that isn't even featured on your graph at all. It's not very realistic here, but like if I wanted to know like something all the way over here that wasn't in my table of values, that would be extrapolation. That might be for like a business or something trying to predict how much money they might be making in future years. Those are all examples of using trend lines for future values. but just a little vocab. I almost said refresher here, a little vocab introduction to what you're really doing when you use a trend line. The password is 628318. All right, for this sample regions question we're taking a look at, it says median diameter of grains of sand in millimeters versus the slope of the beach in degrees. We're going to treat those as our two variables for L1 and L2. So in this case, it says write the linear regression equation, rounding all values to the nearest thousandth. So I'm going to carefully enter these into L1 and L2, and my regression equation looks like this. So nearest thousandth means 3 decimal places. It's 0.159 and then a 3. So it's going to stay 159 for the slope. For the y-intercept, it's 0.4759. So that's going to become 0.476. Sometimes it might be helpful to actually write down what comes off on your calculator screen if you feel like you're making a rounding issue, if you're not sure. This way, if you do hit clear, if you lose what's on your calculator, you could always reference it again to make sure that you rounded correctly. And for part 2, we have a little interpolation question. We're asked, rounding to the nearest tenth, if we have grains of sand with a median diameter of 0.65 millimeters, what would we expect the degree to be? So this is interpolation because this falls within our given values. It's between the 0.85 and some of the smaller values here. So not that that changes anything, but that would be the proper vocabulary. We're basically still going to do the same thing of plugging in for x. We're replacing x with 0.65 here, and we're going to see what we get for y. And rounding to the nearest tenth, we get 8.67, so nearest tenth is going to be 8.7, and the unit here is degrees. 8.7 degrees. And for this final question, slightly different with what we plug in. We're not just going to strictly type in what we see in the table here. If you read carefully, it says use 0 to represent 2007. Basically, instead of treating the year like it's worth 2007, they're going to treat this as the very beginning. So if this is 0, this would be 1, this would be 2, and here's where the trick in this problem comes. It skips 2010. So when you enter in, you're going to type in 0, 1, 2, 4, skips 2012, so 2013 would be represented by 6. If you did this correctly, your regression equation to the nearest hundredth should be 0.16x plus 8.27. So again, sometimes they do this with years in statistics. They don't want to be quite as large, and they're kind of treating the beginning of the survey as 0. Just be careful because it does skips over 2010, so no 4, and it skips over 2012. And now, hopefully, if you had diagnostics on, you already see this on your screen. You don't have to press it again. It said state the correlation coefficient. It's the nearest hundredth. So nearest hundredth, it was 0.97. Determine whether it's a strong or weak. As we've talked about, closer to 1 is going to be a stronger relationship. So this would be a strong, positive correlation between the two variables here, which is year and attendance. Doesn't say in context here, but it can't hurt just to mention what the two variables are. If it does say in context, you want to make sure that you're referencing what you're comparing or what you're saying there's a strong relationship between. So this concludes our final lesson in statistics on linear regression. We'll continue this week with review, a live review on Wednesday, a review sheet, and the exam is going to be conducted on Edulastic once again, like we previously used with quadratics, and that will be this Friday. Thank you all for watching. Have a great day.